Good afternoon, all. My name is Habib Yaro. I am an associate structural engineer with AECOM in Cape Town office. Right, okay. Before we start, I was telling them that I hope this presentation will be a very, it's not going to be a very long presentation. It's really a presentation where I thought maybe I just share with you guys things we already know, we know from university, but it's just to recap it, remind everybody some of the importance of concrete cover and some of the pitfalls that if you get it wrong, how it can affect you. The backdrop of me comparing Eurocode with SANS was because my background was I worked in the UK for some time. So when I came to South Africa, I tried to understand the terminologies, and I was seeing a lot of difference in terminologies. Sometimes they're actually the same, but just a different terminology, and it kept on confusing me. So I thought, maybe I'll just do this presentation on that, maybe just to clarify these things for people that may also find the same issues. So before I start the talk, I've got 4 questions that maybe I want to ask. If you don't mind, later to just post it. Maybe spend maybe a minute or two to answer it, and then we can start the talk. Maybe I'll just discuss the polls quickly. Maybe the first question I ask, which of the statement best describes you? And I wanted to understand how people usually obtain their concrete cover. I mean, I would say I'm kind of a culprit. I always used to just take the old projects and just look at what did they use here and just maybe use that. But I see a lot of people actually do calculate from the beginning, which is about 55%, which is actually very good. So, and you have C, which is a bit of both. So it's quite good to know that most people calculate concrete cover from scratch, which is good. And then the next question was, which of the SANS code can be used for calculating concrete cover? And I gave you 4 options. Now, with the SANS code, it's a little bit tricky. In fact, all the ones that I've given you can use that to calculate the concrete cover. But I see most people have chosen C, which is actually correct. C is I think the most comprehensive one, where it gives you all the other options, the things you look out for. But you can still specify all the other ones. You can still mention that when you're specifying concrete. They are not very detailed like option C. And then the third question I asked, which Eurocode you'd use. I sneakily put in option C, and I put in the wrong Eurocode in just to see whether people pick it up. But I see somebody thought it was wrong, but I actually put it in just to test people. But again, I see people choose the correct one. About 51% chose Eurocode 2, part 1, which is the correct one. And then finally, this is really, which question number 4 is one of the main reasons why I'm doing this talk is what do you call up on your drawings? Because a lot of people have either concrete cover, minimum concrete cover, or nominal concrete cover. Depending on where you are, if you are working in the UK, usually you would use nominal concrete cover. If you're in South Africa, it's very mixed. You can use concrete cover, you can use minimum concrete cover. When to specify which standard you're using, because in the SANS code there is, I think one of the SANS uses nominal concrete cover, and there's one that uses minimum concrete cover, and there's one of them also uses concrete cover. So there is inconsistency in terms of the terminology that they use in the SANS. So people just have to be aware. All right, okay, so that's it. So I'm just going to start with the presentation. At least we've had an interesting little start. So I'm saying what is concrete cover? I mean, that was these are my polls. You can see the question. Just going to jump to the main presentation. So I'm asking the question: what is concrete cover, and why do we need concrete cover? As we all know from university, they've always taught that why we need concrete cover is really it's just to help to protect to protect the reinforcement. And I think what I wanted to do is maybe just before I start, I wanted to give a brief on what I hope to kind of an agenda of the presentation. So I'm going to look at maybe try and answer these questions. What is concrete cover and why do we need to concrete cover? And the next question would be, at what stage of the design do we need to determine concrete cover? And then also the third question was, what factors do we consider when determining concrete cover? And then I'll do a little small calculation and look at concrete, calculating concrete cover in Eurocode, and then one also using the SANS, and we can see the difference. And then finally, I'm just going to talk about one thing which is quite dear to me, looking at tolerances and how it affects one when we are detailing rebars. Okay, so I'm just going to start. So I asked the first question: what is concrete cover? As I said, there are different terminologies. You've got, some people might call it minimum cover. You could also have nominal cover, you've got tolerance, and so on. So these are some of the terminology when it comes to concrete cover. This is just a sketch, so you can see concrete cover is really, if you look at the definition in SANS, it's the distance from the outermost end of the element to the front of the bar, which is your outermost bar. So you can see if you've got a stirrup, your concrete cover is from that point to that point. So that's your concrete cover. So if you've got maybe your stirrups are your main bars are kind of, I'm showing here. Yeah, your concrete cover would then be, you'll have more concrete cover because you have the stirrups in. So maybe in your calculation, you'd have maybe calculate the concrete cover of maybe 35, but actually, because you've got stirrups in the beam, your concrete cover might be more. So you may have to take that into account if you are doing your calculations for a beam design, for example. So that's the definition of concrete cover. I'll maybe jump a little bit further. I will come back to that slide. But so I want to answer why do we need to define concrete cover? Why do we need to know concrete cover? So the main purpose of having a cover in the reinforcement is, as we all know, in reinforced concrete elements, you have the concrete, which is very good in compression, and you've got the steel, which is predominantly what you use for your tensile strength. However, one of the flaws of steel is it's not very good when it comes in contact with very harsh elements in the environment, and that can cause the steel to either corrode or damage. So some of the things that we need to consider when determining concrete cover is how do you protect that steel? Because that's the purpose of having a concrete cover, because you want to protect that steel. So you need to have sufficient cover so that the steel, which is good in tension, doesn't get exposed to the harsh environment. So some of the things to consider, look at corrosion. That's one thing that you need to consider when you are determining concrete cover. And you also need to look at fire. A lot of the time, people actually forget about fire, but fire is actually very important. So when you are determining concrete cover, you need to also consider the influence of fire. And also you have a look at, as I said, like corrosion. Also you've got a very harsh environmental condition. You have to take that into account when considering looking at concrete cover. So things like sulfate attack and so on and so forth. That can have a bearing in terms of what sort of concrete cover you use. And I just put in this picture, which I found on the internet. Thanks to the internet these days, we don't have to go anywhere. We can just, with a click of a button, you can see things that you usually wouldn't find. But this is just a picture of a slab where the concrete cover is not sufficient. You can see all the steel is corroded, it's well harsh, and this, if this is not repaired, this can really cause maybe a damage to the structure, or can cause a failure to a structure that has been maybe designed properly. So this is some other pictures that I found on the internet. Again, you can see the influence of not having sufficient concrete cover. You can see this is a bridge, and some of the columns, you can see all the reinforcement exposed. This is a wall, again, not sufficient concrete cover, and everything's exposed. So these are some of the issues that one can get if we don't specify proper concrete cover. You end up having a structure that you've designed for maybe 50 years, and after a year or two, you find that your structure is degraded, is damaged, and then you've got to go back and fix it. Or if even worse, even a worse scenario, it could even cause a collapse if you are in a very harsh environment. Now, okay, I did mention earlier on in terms of the definition of concrete cover, as in this. I found this picture in the MIStructE manual where it's kind of explains to you what the difference between minimum concrete cover is and nominal concrete cover is. In SANS, I'll get to that shortly, but I find the Eurocode definition of nominal concrete cover quite clear without any ambiguity, because it tells you your nominal concrete cover is equal to minimum concrete cover plus any deviation that you have. And then if you look at the standard, it's quite clear what this minimum concrete cover is and what this standard deviation is. So that is what you get in terms of if you want to put in either nominal concrete cover or minimum concrete cover. So for some of our guys that are working for international companies or doing projects outside South Africa, if you are specifying, if you want to specify nominal concrete cover, I would say, the way I usually do it, I will just put in nominal cover is equal to the minimum plus standard deviation, and that way there isn't any ambiguity, and people know what they are seeing, so they don't get confused between what is nominal and what is minimum. And this is kind of this kind of diagram explained is clearly actually. So you can see nominal concrete cover is your minimum and plus your standard deviation. And this nominal concrete cover is what you usually put on your drawing, not the minimum. So because that is the cover that you would expect on site. So either in the South African term or in the European term or British term, the cover that you put is this nominal cover, whether you call it nominal or minimum, but that's what you put on the drawings, your nominal concrete cover. Yeah. Again, I just came back here. I'm just showing this the SANS clauses, where I'm just kind of highlight the fact that there's a lot of differences in terms of terminology. If you look at SANS 10.144, it talks about nominal concrete cover, nominal cover. And then when you look at SANS 10.100, it talks about minimum concrete cover. So this is what I was mentioning to you guys earlier on, that there is kind of a difference in terminology, and it can be somewhat confusing. Although if you really look deep in, you find that it's actually talking about the same. So whereas if I go back whereas in the European term, when they talk about nominal concrete, they mean minimum plus standard deviation. In the SANS, there isn't any kind of differentiation. They just give you the cover, which is your cover, which is the minimum or your nominal, depending on how you want to call it. So I can see it in here, which is SANS 10.100 -2. It gives you different exposure classes, and it's giving you the different concrete, minimum concrete. It says minimum. So in here, it says concrete cover. So depending on which one you are using or which in your specification, what you've used. So if you are specifying using SANS 10.144, you may use nominal, but if you are specifying to SANS 10.100, you then can use just the concrete cover. But you just have to make sure it's in your specification so that there isn't any ambiguity. Now, hopefully this has cleared the air. Most people understand what the difference between the two is. But really, minimum concrete cover in South African terms is different to minimum in if you are working on a project which is maybe outside South Africa. So we just have to be careful. So maybe the next point is at what stage do we consider, do we kind of determine concrete cover? Now, maybe if I just go here, I should have actually done a question on this one here, but I'll just run it through. So you've got scheme design, you've got detailed design, you've got construction stage design. usually, I mean, the best time to determine your what's the name, your concrete cover would be at the very, very early stages of your design. This is something you need to maybe agree right early at the design, even before you do any serious thing, because the concrete cover can have a huge effect in terms of how you design your elements and so on and so forth. So the time at which you decide to determine your concrete cover would be at scheme design, right at the early stages, not when you are detailed design. You want to come and change the concrete cover. You need to determine your concrete cover right at the beginning, because also that also has got a knock-on effect in terms of what sort of buildings you have, what sort of structural class you have. So that's all done at the initial stages during scheme design. So as I say, the next is what factors do you consider, or do we consider when determining concrete cover? I think I may have mentioned it already in my intro. The purpose of the concrete cover, which is really to protect the reinforcement. So with that in mind, these are some of the factors that you consider when determining concrete cover. The first is the size of the reinforcement. Then the second is fire, which I mentioned earlier on. So in the SANS code, the part of the code that deals with fire is SANS 10100/2. And the Eurocode, the part of the Eurocode that deals with fire is Eurocode 1992/1.2, which is the fire. And then the next factor that we've got to consider when determining concrete cover is the degree and nature of the exposure class, what this means is the environment in which your building is going to be located, or your element. Is it somewhere close to the sea? Is it somewhere where you don't have a harsh environment? So all this has an impact in terms of determining the concrete cover. And you can say I've just added corrosion protection, because really the thing we're trying to protect is the steel, which is ultimately the corrosion of that steel. And the other thing is also the concrete mix. So the concrete mix also can have an influence in terms of what concrete cover you use, with the concrete strength, and so on and so forth. So that's also a factor that we need to consider. So as I said, you need to determine your concrete cover at the beginning of the project. So these are some of the things you have to already start thinking about. What concrete mix am I going to use? What sort of bars am I going to use? I'm going to use bundle bars. You start thinking about these things, because they can have a knock-on effect in terms of what concrete cover you use. I mean, for example, if you decide to use maybe your standard concrete cover using standard bars and end up using bundles, that can have an effect on your concrete cover. Or if you decide, okay, during scheme design, I'm going to use a rebar of maybe 16s, and during detailed design, you realize, oh no, I've got to change to 32s. That can have an impact on the concrete cover. So it's worth us just understanding all these factors, how they affect concrete cover. And we shouldn't always put concrete cover at the back end. It's just pick it up from the design or old design and just use whatever is there. So because these can have a knock-on effect. Okay, let's go. Okay, right. Okay, so I've just put in some, as I said earlier, or maybe I might go back here. It's if I talk about the rebar, the factors of rebar. Maybe I just have to mention. Usually, when you are calculating concrete cover, you have to ensure that the minimum, the bar size, your concrete cover is at least equal to the size of your bar. That's why I was talking about the bundles. If, for example, if you go for a concrete cover of maybe 25, and you decide, okay, during detailed design, I'm going to change my bars to 32s, but then you forget to go back and change your cover to 35. You realize that you have under designed for a concrete cover, because your bars are so huge and your cover is still 25, whereas your cover should increase to maybe 32s. And if, for example, you decide to use a bundles instead of single bars, if you've got 4 bundles, you have to make sure the size of a concrete cover is equivalent to that entire area. So that can also have a knock-on effect. And obvious fire, you should know that at the beginning. Exposure class, you should also know that. But really, it's one of the things that tend to bite people is the size of your rebar. If you get that wrong or you change it, it can affect your concrete cover. And these are some of, as I said, in terms of the SANS code, SANS 10100. There is a table 3, which kind of gives you. I'll say that the SANS, the SANS is very descriptive, and there's like it just tells you this is what you use. It doesn't kind of give you. It's not very academic. Whereas in the Eurocode, you've got to find this table, you've got to do this, you've got to match these. So that's quite a few things you've got to match. So in the SANS, you've got the SANS table 3, where it gives you the different exposure class. You've got moderate, severe, very severe, extreme, and it just gives you, again, as I said, minimum concrete cover. It has the definitions of these. So if you are using the concrete grade of 20, your cover is going to be about 50 for a moderate condition. If you are using concrete grade of 20, you can't actually use it for a severe condition because it's not available. So you need to maybe beef up your concrete grade. Again, if you are in a very severe condition, your minimum concrete grade should be at least 40, not 30. So all these things the SANS kind of guides you in terms of when you specify your concrete, which is what I mentioned earlier on, how concrete grade can have an influence on your concrete cover. And when you come to the Eurocode, which is on the right, here it gives you the different class. As I said, the Eurocode has got lots of tables here. It's got, as I said, based on. Sorry, apologies for that. Based on the different structural classes, you have different. It gives you again different tables. If you've got class 4, it tells you what exposure class you are in, and then it tells you which concrete cover you should use. But again, we'll look into this when we look at that example, a simple example. Okay, so that is kind of your main factor. So as I said, I'm going to do a simple example of a concrete calculation. So we've got a scenario where I've said you've got to calculate the concrete cover for a simple supported concrete beam within a building using the following data. So if I'm saying you are in your site condition is close to the sea. So if somebody's in Cape Town, maybe your building is close to the sea. So they're really close to the sea. So you're looking at a very extreme condition. You've got a minimum fire resistance of 90 minutes. You've got a concrete strength of C3240, and then you've got your minimum aggregate of 20, and your main bar diameter is 32. And you've got a design life of 50 years. So if we do the Eurocode first, what do you consider? So in Eurocode, as I said, it kind of spells things out for you, gives you more control of what you want to do. So there is, as I said, you've got nominal concrete cover is equal to minimum concrete cover plus your standard deviation. And then your minimum concrete cover, it tells you these 4 of them, 3 of them, 3 conditions that you need to comply. So you need to look at the maximum of these. So the first one is you need to look at your bond, minimum cover due to your bond. So that is CMB, and it's a table that you use to calculate that. And then there is a next one is CM due to durability, which is the environmental condition. And then there's another one, which is an additional safety. If you've got a very, maybe a very special or maybe critical element that you want to add some additional safety, the code allows you to add some additional value to the cover, which beefs up your concrete cover. And then if you have things like stainless steel, because those ones don't need too much cover, they're already protected by nature, the code allows you to be able to deduct some of reduce your concrete cover slightly. So for stainless steel, you can reduce it. And if say for example, on site you've got a very rigorous method of checking, and you are confident, you can say, okay, I'm happy with maybe discuss with the contractor and making sure you put things in place to be able to monitor. You can then reduce your concrete cover again. There's a small little kind of reduction as well, which they've called additional protection. So with this in mind, with this condition, we can start. So the first thing we need to check is we're looking at the bond, which is the bond requirement. So Eurocode gives you a table 4.2. Again, comes back to here. The minimum is to do with your minimum diameter, which is what I mentioned. So for 32, your minimum CEng should be 32. So that's our first value. Then the next, so go back here. So we've got this as 32. The next one is to do with the durability. So if I go back again, which is the one here, which is the durability. So Eurocode kind of, as I say, it's a bit more detailed. It looks at the category of your element or your building. So, for example, we've got if you look at Eurocode 1, you've got your category. So you've got category 1, which is class 1, 2, 3, 4, 5, and that's all got to do with the different working life. So for us, we've got to build a building. So we're looking at around class 4. That's just a building. So class 4, so you get to your class 4. From there, you take this, you move to this table here. It gives you, before we get to this table, we look at our condition, our exposure class. So we said we are somewhere in Cape Town. As we all know, Cape Town close to the sea, so it's a very harsh environment. So I'd say, if I'm going to be very conservative, I'll say maybe class XS1, which is close to the coast. So with these two in mind, you take these two values, you go to this table, you're looking at S4, and then you've got this class. So if you move down here, you're looking at about 35 minimum concrete cover. That's what I'm showing you, got the minimum concrete cover of 35. Now, as I said, I mentioned this earlier on. If you depending on which part of Europe you work in, like, you have to just look at the national annex, and this tells you what to use for these other values. Okay. Now, as I mentioned earlier on, fire is also very important. So in the Eurocode 1992 1/2, it talks about fire, and in here it gives you different it goes into very detail in terms of how you calculate the cover for fire. But in a simplified method, what it does, there's this little table here, and if you're familiar with the Eurocode, you see there's this table, this figure here, where it gives you this value, this A value. So this A value is really it's not the same as our normal concrete cover. It's actually the distance from the underside of your element to the center of your main bar. So from this, you can actually calculate your concrete cover. So as from our example, you can then calculate this A value from this table, depending on what your grade, your fire resistance is. So we know it's a 90 minutes fire resistance, which is there. I mean, you could give some initial kind of element sizes. If we say maybe 150, for example, and you could come somewhere here, maybe we said about 40, depending on what the width of your beam is. If we say, for example, it's 40, we're using 40 in this instance. We've got 40, so that is 40 plus your allowance. There's an additional allowance here, which gives you 50. So your minimum concrete cover, if you work this back, it's these values, which is the other way around, and you end up with your nominal concrete cover as 24, which is way less than what we calculated for. But then if I go next, so then you then have to compare all the ones that you've calculated, all the 4 that you've calculated, and the maximum is going to be the one that you use for your minimum concrete cover. So you look at 32, 35, and there's a 10, and then you also got your fire, which is 24. So your minimum concrete cover is the maximum of all those, so that gives you 35. But then your nominal concrete cover now is the minimum plus the additional 10, which gives you a 45 mil concrete cover in terms of the Eurocode. So you can see the sequence of how this has been calculated. It's simple, but it's a bit of a journey if you compare that to the SANS. So if I go to the next one, I'll be looking at SANS. As I say, the SANS is pretty straightforward. I mean, there are two. I mean, if you look at SANS 10-100, there's this table here where it gives you concrete grade, and as I said, if you are looking at, we're looking at 3240, so we're looking at somewhere between 40 and 50, and then we've got again in South Africa, Cape Town, maybe severe. We're looking at about between 45 and 50. So really, within just one table, you're able to get your concrete cover using the SANS. But again, the SANS is as I say, it's quite quick to get this. But the Eurocode kind of goes into more detail. You know what you are calculating. Again, as I said, the next is the fire. So in the SANS, you also have a fire, but unlike the Eurocode where you've got your minimum and then you need to add the standard deviation, the SANS, it just gives you the nominal for fire, and then you got your minimum. So you just choose the one that is the biggest among them. So you can see you've got for fire, you've got 35. For durability, you've got 45. Oh, I nearly forgot. The SANS also you've got also for concrete for the rebar as well, where it talks about your nominal concrete cover should be equal to the bar diameter, or if it's bundles, it should be equal to the equivalent of the it should be equal diameter of a single bar equivalent to that area of the bundle. So just be careful you are using bundles, because your concrete cover is going to be huge. Okay, and this is just for the fire. So you can see the SANS, it's quite quick. Within a short period, you can just come up with your cover, which is incidentally, it's actually the same as the Eurocode. So I'll just leave it to you guys to determine which one is easy to do, but at least this is the way to calculate concrete cover when you compare SANS and Eurocode. Now, finally, I'm just going to talk about this thing, which is kind of, like I said, I thought the meeting was going to be short, but anyway, I think I've got a bit far. But it's this concept of shed when you are shedding a rebar. I don't know how many people are detailing rebar using the Revit, but I know a lot of companies are now using the Revit for detailing rebar, doing 3D rebar detailing, and so on and so forth. So in those instances, one has to be very careful when you are determining what your cover is, because if you get your cover wrong, that can have a big knock-on effect in terms of what you've done and how your scheduling appears on your drawing. You might totally get your scheduling wrong. Now, there is this clause in the code where it talks about scheduling when you've got bars that are bounded by two surfaces. Now, a lot of people tend to forget this requirement, but in fact, it's actually very important, because what the code says is if you've got a bar that is bounded by two surfaces, the length of the bar that is within that two surfaces, you need to make a deduction, and the rationale behind that is when they think is, if for example you've got a beam and you've got a stirrup, and say for example you specified a cover of 35, and then for example the contractor builds it, and maybe he maybe builds it slightly bigger, which is within his tolerance. If it's bigger, a little bit bigger, what you find out your bar is now going to be sticking into your cover, which is not what you want. So what the code is saying, if you've got an element bounded by two surfaces, there is a deduction that you need to apply to the bar, and this is actually a code requirement. So everybody should do that whenever you are detailing reinforcement. And I go next. So this is really the code requirement. So in in SANS, it's this table here where it says if you've got an element which is a meter, between 0 and a meter, you need to deduct 10 mil from whatever bar you have. And if it's between 1 meter and 2 meters, it's also still 10 meters. If it's over 2 meters, it's 15 mil, sorry, 15 mil, yeah. Whereas in the Eurocode or British Standard, it gives you kind of a lot more options. So if you are less than 200 mil, you need to deduct 5 mil. If you are less than 400, 10 mil. If you are less than between 400 and 1,000, 15, and so on and so forth. And if you are above 2 meters, you need to deduct 30 mil. So as designers, we all have to be aware of these things, because if you're detailing some bars and you're using lots of big U bars, and you've got very highly utilized beams, for example. If you're not aware of this, you might, and maybe you've designed your beam maybe to a utilization of maybe 0.99, for example. But in fact, when one goes to detail this, because of this requirement, your beam your main reinforcement may be higher than where you've assumed. So now you find that your beam is actually not working, because just by moving the bar by maybe 10.5 mil, the bar that is utilized, your beam that is about 99.9 utilization, now you find that it's failing now. So designers have to be aware of this clause, so that when you design, you're aware that you have to allow for some a little bit of tolerance in your design, so that in case these tolerances are applied to the scheduling, your element will still work. And these are some photos that I did. I don't know the guys helped me just to explain this theory. So as I said, let's say you've got this U bar, and you've got to specify this U bar in your scheduling. So let's assume this L value is maybe 2 meters. So your C value, this value in your bar, you'd have to reduce it by the cover plus that deduction. If I go back up, this L is 2 meters. If you're in SANS, you have to deduce it by 50 mil. So that will just make everything smaller. And again, if you've got a stirrup, similarly, you also have to do that deduction. So as I said, if you've got to reduce this by say 15 mil, everything then goes up. So by it going up, that can really affect your design. So as designers, we just need to be careful about these things and not leave things to chance, because I know a lot of the time we detail and we give it to somebody to do the reinforcement, but actually these things can come back to kind of bite us if we're not very careful about it. And then finally, there's a straight bar. Usually straight bar, we don't really worry about them. But again, if you've got a straight bar which is bounded by two surfaces, again, the code says you need to deduct 10 mil out of that. So again, you need to just make sure you don't get your bars banked right to the edge of your element. Okay. So what else? I think that is. Oh, okay, fine. Like I thought maybe I just show how you get covers from sites. These are some of the spaces that you use to create covers. I think I found it in one of the books. And there's a picture here of how you get covers, which is you can either use there's concrete spaces, or you can use the plastic ones, or you can also use these kind of chairs as well for top. Say if you've got a top T1 and T2, you have your chairs in, which is we just detail your chair so that it's with you still get your minimum cover. Okay, that's it. So that's it. As I said, this was supposed to be a very short presentation, and really the presentation was just to highlight things we already know, which is concrete cover. As I said, it's something very simple, but yet we can get it wrong. And with the way we are modeling now, as I said, a lot of companies are now modeling in 3D. If you get your concrete cover wrong, if you don't get it, if you don't detail it or you don't specify right at the beginning and you wait right at the end, that can really affect whatever you've done, and it can cause you to do a lot of work, maybe even set you back. So really, as I said, it's a simple presentation, nothing complex about this. But I hope most of you will take a lot out of this when you are detailing, when you are specifying, that you don't take concrete cover for granted, because it can come and bite you and as they say. So that's me.